So we have hashtag aspect and Roma here. This means we can start. Okay. So the meeting today is kind of twofold. It has two purposes. The second one is the usual purpose of bringing you constant updates about what the Rusty crew has been up to and what they plan to be up to afterwards, and what's going on in general with development. Other than that, before that, we want to have an update which includes some debates and questions, dialogue between Roma and Jonathan, followed by taking questions from the audience about doing ZK smart contracts on Kaspa and introducing a ZK opcode and using it to do all sorts of cool layer 2 stuff on Kaspa. And so without further ado, let hashtag and Roma and Aspect take the stage and tell us everything they've been working on recently. Yoni, you're muted in case you don't.
Shai, can you hear me?
I can hear you well. I can't hear Yoni because he's muted.
Jonathan.
Yoni.
Well, okay, here we go.
Can you hear me?
Not very good. Should I talk about some of the things we've been working on while we wait?
Just give me a second. Yeah, no, they're having small technical connectivity issues. So they'll start just in a minute. We can build tech like Kaspa, but video chatting is still shit in 2024. Huh. Well, you haven't seen anything before you've seen 4 computer science professors trying to set up a projector. Say something, Jonathan. No. I think they are having like problems with the internet in the house. So one day there will be an interview and we can hear Jonathan well. One day.
Maybe try changing the device, like moving from, I don't know, phone to laptop or something like this.
Okay, he sent me a message to start. So, Roma, maybe you want to take the lead here and tell us what you've been up to? Don't tell me we lost Roma too.
Well, you want to start with the overview?
Yeah, sure. I can. I was a bit expecting like to having.
We seem to hear you wrong. That's a bunch of people who are trying to create cutting edge cryptocurrency network.
Hear me now?
Yes.
Yeah, it's all gonna be much better when
Yes.
Discord is on Kaspa.
Fuck.
Concise. That
Like
was a
we
concise
are
message.
running on top of Bitcoin, right? This video streaming is on top of Bitcoin.
Yeah, every 10 minutes you get everything said at once.
Yeah, I hardly can speak. It's
You're very delayed.
slugging.
You keep responding to stuff we said 2 minutes ago.
Free.
Do you want me to
maybe try to switch off the
okay.
Great success.
Just a second. Okay, so Anton, maybe you dive into it
What do you-
first?
What do you want me to hit? I can do.
Look, maybe we'll move on the agenda and we get back later.
I
to
can
the
do
ZK.
a agenda or ZK, whichever. Okay. Well, the agenda is more a general update on our side of the fence. It's been a while since we had a public meeting, so wanted to kind of give a quick overview of different things, different core contributors have been working on, including myself. As many of you know, we have made a release a couple months back with a WASM release, which is a basically a Rusty-kaspa framework being built into WebAssembly, which allows it to be used as within TypeScript and JavaScript environments. And we already had that since a long time ago, but it was more JavaScript focused. So a major change was introduction of TypeScript bindings. So now effectively all functionality, including RPC access to the node, everything you need to interface with the wallets and such is effectively available on in any TypeScript or JavaScript environment. It works really well, very solid. It works within web applications as well in the browser. And if anybody has any questions, just find me or anybody on the development channel, and we'll guide you. There's examples and such. There's a number of projects that are coming out that are based on that. The one that's well known is StarkWare, and Kafin is also working on Caspian, which are browser extensions. So since that release, there's another quite a large update coming with different features. There's some proof of work related functionality, as well as a script builder, which allows you to build transactions. As well as recently we added things like priority UTXO selection in transaction generator, which all is kind of based around making it easier to create more custom scripts and custom transactions. Another major thing that took place ongoing right now is we're, as the developers in this group know, we are, Rusty-kaspa has two RPC interfaces, gRPC and wRPC, and wRPC is WebSocket based, which allows it to interface with web applications. That's what powers WASM libraries as well. And I've been for the last couple of weeks working on a major protocol refactoring. So in the coming weeks, there will be an update that will break a wRPC compatibility. Everybody who is in the ecosystem, all the developers are aware of that, and there is nobody will feel anything in relation to that because there's going to be a gradual switch. But the new kind of updated protocol is much more forward-looking. It will allow us to expand the protocol further down the road without having any backward compatibility issues with clients using that. As some of you might have observed, there has been a rather interesting situation created by the KRC-20 launch, which was actually twofold. One that was revolving around network getting oversaturated with transactions and not and tools not really supporting proper transaction fee management, priority fee management. So that's one of the sides. Maxim is currently working on that. We're working to facilitate an RPC call for automated fee calculation and related functionality. And simultaneously, as I kept saying to everybody, is that if you don't believe in Murphy's laws, you should. Basically, the day before that, some of the people who are running public nodes had problems with their hosting provider, which brought some nodes down, and as a result. What happened is that we have, within a matter of hours, with StarkWare release, the network backing this has gone up from something like 100 concurrent clients to over 20,000 basically wallets being connected, and things got oversaturated. It was actually quite fascinating to see. Took a couple of hours to understand what's where, mitigate the problem. Then eventually the other nodes, everything came back gradually. I've made a community outreach on X, asking people to power up public nodes. And at this point, we have over 14 people that came forward, and with over 20 VPSs and different machines and nodes being basically in the queue for that, which resulted more of a management challenge. So for this week, I have been kind of simultaneously working on multiple fronts to create a small automation tool that makes these things easy to handle, as well as facilitate all the upgrades. And basically, in a couple of days, I'm hoping toward the end of the week, we should start powering up the new kind of public node network, which will be backing all this infrastructure. To people who are curious about that, the way this sort of functions is that we have a peer-to-peer network, which is the Kaspa network, and the nodes can basically opt in to become public and make themselves available to basically web clients. So it's, in a way, it's a subset of the peer-to-peer network. And then we have something called resolvers, which are basically small applications that sit on top of that, and they're listening to all the nodes and see how loaded they are, and they distribute connections in between. So it's a kind of a three-layer network solution. Anybody who has a permanent VPS or a setup can simply basically turn on this functionality, and the load will be shared to their node as well. So that's taking place, and I wanted to thank everybody who has basically contributed. You guys are great. This is really an astonishing. Never in my life have I seen where you just kind of flip fingers and there is just this crowd of people standing in front of you asking how you can help. How can they help? So that's pretty awesome. The couple of other things to touch on.
I'm sorry to interrupt you, but I see that Roma and Yoni are, we got them back. So I think maybe we'll move on to the start of the agenda, and then we'll have the rest of the updates after their part.
You should do the updates before the agenda. This way.
But I got a specific request to start with the.
Okay.
With the AZK. Yeah. So let's do that.
You want to set it up wrap up your updates?
We can't hear you, Yoni. I can't believe this.
No, I could hear him better now.
Yeah, I think it's just the microphone now.
You want Anton to finish the update?
I can pick that up after. That's fine.
Hi, is this now okay?
Better if you continue speaking continuously.
Okay, so just raise your hand if you can't hear me. So regarding the, yeah, but everyone says they can hear me, Shai. So I get like many raises of the hands.
Okay. Now that it's closer, I can hear you better too. Keep going.
Okay, so just to be clear, the way I see it is, I was asked to speak about smart contract design and ZKVM. So there's first and foremost, I want to make it clear that on my personal priority and focus, smart contract is not on the top two, rather high BPS and DAG-Knight are. And then I'm happy for for others, for Roman, for Anton, and for others to lead in parallel the smart contract efforts. But I'm focused on the base layer, on the base consensus improvement. Now, my general design or the general design I recommend for Kaspa smart contract is based rollups, which was known as originally simply as rollups. And rollups, meaning all sequencing and data availability is via layer 1, and just full nodes of Kaspa don't need to compute the smart contract state. They just need to verify it through a succinct proofs. So this is building on the verification and computation gap that is enabled by the ZKP tech. I'm not sure if the stage is ready for questions, Shai. How does it go? I just continue on, or maybe you want to ask questions, Shai?
For questions in the chat for now. After you finish your talk, we'll maybe put up some speakers.
Okay. So also there's a general misconception that smart contracts on DAG are a challenge. So I want to refute this myth. Enabling smart contract on Kaspa is at most a few weeks job, a few weeks work. Implementing an opcode that allows to verify proofs. Roman and I designed such an opcode. We can provide a better spec of it, but currently we are fully aligned on the details of the opcode. Now, the prover in this opcode should be inclusive to the several circuits that are that of the leading tech in the community, but there's no need to be like there's not more than 2 or 3 leading proving systems in the community. Maybe versions of Starks or Snarks. Roman would survey this. Is a better source for serving this than me. Now, but that's only the minimal feature on L1. But if you really want a smart contract ecosystem, you need to support it. And here there are two extreme paths, which Roman and I and also Anton and others and Satan are discussing. One is to plug into an existing VM or ZKVM ecosystem and reusing or just plugging into their ecosystem or reusing, friendly clones of their ecosystem, of their code bases. And then this is one extreme, and the other extreme is to build things from scratch, with the trade-off being that building things from scratch can potentially better utilize the technology of Kaspa, the speed, design that is more suitable for our features, mainly the speed, but if we develop everything native, the tooling, SDK, everything would take order of magnitude longer to develop. I will let Roman elaborate on this. I do want to mention one thing. When I say we are going with based rollups, this is not to say that other models will not be enabled. If someone wants to enable their own model of rollups, so on top of Ethereum, most of rollups or leading rollups are not based in the sense that they do not use they use their own sequencer or their own shared sequencers. They don't use ETH L1 for sequencing. But so if someone wants to implement such a system on top of Kaspa, they should be able and welcome to do so. But our design should focus on the sequencing properties of Kaspa, especially due to the speed and especially due to the MEV resistance, which I'm working on. And so basically, I think I provided the main points that or the main updates. I'll let Roman survey the tech and the available the available ZKVMs, and then if there's questions, or Shai, if you have specific guidelines, what the people are asking in the chat, then I can elaborate on that.
Yeah, currently they're mostly asking about Nacho, so you could keep going.
Okay, I suggest now Roman speaks and just surveys the different tech that we should consider versus the native Rust option.
Sure, the floor is yours, Roman.
Okay, so yeah, so I will maybe do a quick overview of ZK technology in general.
Is it frozen for everyone or just for me?
For everyone.
Okay, just a second.
It's just like okay.
Yeah,
it's just like
it came back. Okay, so there are few very solid options in the field with different velocity. No, it doesn't work.
Turn off
No,
your camera.
he
Turn off
did.
your camera, Roman. He did?
Are you guys
So I
hear
just
me?
got this frozen
Yoni,
image.
raise your hand.
Yeah, Discord is not the best. And it looks like there's a lot of lag because
No.
Roman was sitting for a while.
So maybe until Roman comes up, I will complement his survey. You know what I know of his survey. So there's we're not
How about it now?
the ZK tech. Roman. Shai, can I continue?
Yeah, continue.
Okay, so until Roman comes online, I don't understand people that don't have good internet connections or good microphone. I don't understand these people. Anyways,
Yeah, guys, can you hear me?
Yes, Roman. Yes, the bell.
He needs to timestamp his messages so we can figure out the delay.
Yeah, it's just like carry C20. The second you start sending something, it gets oversaturated.
So there's, anyways, plugging into an existing ecosystem. So I want to explain what it can entail, what the different options. There is we won't implement write our own prover. So obviously use an existing prover. So whether it's a ZK ZK VM of Polygon, or there's SP1 of Succinct Labs, there's the Cairo StarkWare system, which, by the way, we have a representative here. Shai, maybe allow him to speak on stage. So
Ilya?
Yeah.
Can you please request to be a speaker? I don't think he's following.
So
Okay, just he sent me a telegram. Requests are disabled. Okay.
Guys, do you hear me?
Barely.
okay, Shai.
Roma, maybe exit whatever you're running also. Maybe this is not bandwidth, but CPU load somehow.
Okay, you figure this out. I'll figure out how to let Ilya be a speaker.
Okay, so again, if we plug into an existing ecosystem, this means not only using their prover, but rather the entire state handling, all the stack of the smart contract. And then the only thing that we implement is the opcode, the verifier opcode, and some integration. Whether this takes, this could take a few months, but this shouldn't take much more than that. Whereas if we use only an existing ecosystem's prover or existing code base prover, and we write our own version of how the smart contracts work in our own stack, then this can take at least at least 18 months. So, but it will be more native to both to Rust and to Kaspa. The thing that I'll give an example what one would want to optimize in such an environment. So I'm building on a discussion I had with Roman. There's a lot of discussion in the community, in the VM community, about parallelized VMs, and while this is a sexy term, it still needs to be researched how much of DeFi state are actual hotspots, meaning that you can't really decouple DeFi activity. So for instance, if most of the activity is touching the same global variables in Uniswap, I don't know, Curve, Balanced, and DYDX, then you won't really utilize anything by parallelizing the VM. Whereas if most of the activity is can be decoupled, then you can utilize not only multi-core on the hardware level, but also on a software level, design it such that smart contracts interact with one another through micro ZKP. This is the direction. This is the more native Kaspa native direction. Again, it's not like what you are familiar with from other ecosystems where you have a gigantic state, under maybe Arbitrum rollup, under Stark rollup, under Optimism rollup, but rather each smart contract area provides their own ZKP, so it's more flexible. But it's still, we need still to do some research to see how many like not sure in what units, but how many independent components there are in DeFi activity. Obviously, ERC20 trading is highly parallelizable. But if we do find out that there's lots of room for parallelism, then Kaspa should go down the native route, because that will build on our strengths. Whereas if we find out that there are only a few hotspots, there are a few hotspots or bottlenecks, then we won't go down the parallelization route. This is something that Roman and I are still surveying. Until Roman connects, Ilya can tell us about the prover of their ecosystem and what he will go about. So maybe it's a good time to jump to Ilya now.
Hello, can you hear me?
Mm-hmm.
Cool. So should I start off with overviewing the architecture of Starknet as a rollup, or of rollups in general, or should I just skip to the cryptography?
Architecture.
Okay, cool. So I I work at a rollup called Starknet. I think the architecture of many rollups are pretty similar, but I'll focus on what I know. So there's a few layers to the stack. The first layer is the VM itself. This is the state machine whose transitions you prove to the L1. You have the high-level language in which you write contracts. That's the stuff you use to express whatever computations you want to happen. And you have the underlying cryptography, which is the proof protocol you choose. It can be snarks, it can be starks, or flavors of those. In a nutshell, what happens in Stark-based proof systems is you have an algebraic representation of your VM, some encoding of it that you can input to proving protocols, and this representation is something that's it's a bit of a hassle to generate, but you only do it once. It represents usually something like a CPU that you can use to prove general computations. And then the high-level language, when you write contracts, it compiles down to instructions for the VM, and then you can prove the execution of those instructions.
If I may quickly ask, what is high-level language?
In Starknet or in general? I'm not sure I understand.
In your platform, in the context of Starknet.
For us, it's Cairo. There is Cairo as a language that's completely separate from blockchain, and it also has additional syntax for writing contracts on the blockchain. In other rollups, I think the common ones are EVM-based rollups. Usually, the preferred language is Solidity or some Solidity Prime, which is just a minor deviation from it. On Solana, they took Rust and gave it a blockchain syntax. So usually, either a made-up or an existing language that's already used for writing contracts, or a widely adopted one with some extra syntax for writing contracts.
Yeah, can you compare the Solana Rust language to Cairo? Specifically, what is for a Rust developer? What is most intuitive? What's the smallest delta to work with? If it's non-negligible.
I don't think I'm the right person to ask this question because I haven't written contracts on Solana. Oh, sorry.
The key element, it's not really about it's not about Solana or anything here. Is that there are different platforms. Let's say when we talk about Solidity, that refers to ZKVM, which is how can I describe it in general terms? That is platform specific because this means that the VM itself has a context because Solidity is related. It's not a general purpose programming language, whereas almost all programming languages, well, not all at all, but a subset of modern program languages can be compiled into bytecode, LLM, which is LVM, yeah, which is an intermediate bytecode, which allows then basically smart contracts, or for that matter, not just smart contracts, any code to run within the ZKVM effectively. That's one of the very attractive advantages in these platforms is that it makes the system technology how can I say it? Smart contract technology agnostic. Let's put it this way. But sorry, I didn't mean to interrupt. But this is not really the comparison. It's more there are two categories of systems. One category of system which has let's say a ZK EVM, and the E in there talks about Ethereum, which is based around Ethereum technology. So if anybody utilizes that, you are effectively locking yourself within the Ethereum-like ecosystem. You cannot get out of that. Whereas the other stack, which is a ZKVM, where you are able to program with anything, do anything. You're unbound by the smart contract technology, and then the smart contract technology you develop on top. This is what is there's pros and cons to anything. From architectural standpoint, the zkVM itself is very attractive because from architectural standpoint, you do not want to be locked to any specific technology when it comes to actual smart contract.
I wanted to ask Ilya again about the difference, the delta for a Rust developer. Sorry to interrupt, Anton. Just to utilize Ilya's presence here. What's the delta for a Rust developer to use Cairo?
So first of all, start by saying in Solana it's probably a bit smaller because I think their extra blockchain syntax is a bit more minimal. I think it's less well thought out. For Cairo, it's a bit more. The typing is a bit different, and you need to work a bit harder. But Cairo has a lot of work on compiling both to Chasm, to Cairo assembly, and it also compiles down to a safe intermediate representation, which it's dedicated to blockchains, and it protects the sequencers from various DOSes in case malicious users send unprovable transactions. So from Cairo, it's probably a bit, not a lot, but a bit more work. But you get a lot more, in my opinion. I can elaborate on the intermediate representation, but I don't think it's very crucial here. I also want very quickly to address what Aspect said. I do think it's worthwhile to. Sorry?
Just before that, I want to see if Roma is back with us. Okay. Roma, can you say something? Okay. Yeah.
You hear me now?
Yes, can you hear us?
Yes, looks like.
Okay. That took less than 2 minutes.
No, I didn't realize, like,
Can we just proceed with Ilya? Let's
move on with what Ilya had to say.
Discussion.
Sorry.
So Ilya, can you just repeat what's the just to have the continuous discussion? What's the reason Cairo is different than Rust, and you said it's not a big deal for the Rust developer to.
Rust has nothing to do with the blockchain, so it doesn't have any syntax for writing contracts, and it doesn't have any basically blockchain context. So you need to enrich it to allow people to write contracts meaningfully. Now there's 2 ways you can go about this. One, well, not 2 ways, 2 instances. Solana did add their own blockchain context, and Cairo went in a different way and added their own. And what I said is that it's inevitable that you will have some diff. Unless all you're interested in is running and not writing contracts, but just proving the execution of Rust programs, which is different than being able to write contracts. So you will have a diff anyway. But something which I think is unique to Cairo is that there is the compiler from high-level Cairo to Cairo assembly has an intermediate step where it goes through a very interesting safe representation, which is built to protect the sequencer from DOS. So it's more blockchain oriented than just adding a contract context. I don't mind elaborating this, but I figure maybe it's not necessary in this setting.
And then I have 2 questions. One is about the modularity, and the second about the licensing. Is Cairo open license open, and then how modular is it to replace the sequencer?
I don't understand the second question. What do you mean by replacing the sequencer? Cairo is a language which has nothing to do with.
Is it special? What? Sorry.
No, Can you repeat your question?
I guess with respect to Cairo, it's just a language. So yeah, my question doesn't make sense. I meant more on the stack. So you have your stack, the full stack of I guess Starknet. That's the name of the entire stack that's built on top of Cairo, not Cairo itself.
Yeah, but I think
so within Cairo, you're agnostic to the sequencer.
Completely agnostic. They're unrelated things. Cairo is a language with which you can write. You can express general computation with it, and you can also write contracts. And that's the end of Cairo. And Starknet is just the name of a rollup which uses Cairo and happens to choose a particular architecture, but it's completely unrelated.
Okay, fine. Okay, so the second question about licensing.
Yeah, anyone can use it or whatever. Yes.
Okay, cool. And then you wanted to mention another thing before we interrupted you. You had another point you wanted to emphasize.
Yeah, just to address something Aspect says, I think it's worth separating between the VM and the high-level language. at the end of the day, as long as the VM has, as long as its instructions are expressive enough, you can always work hard and write a compiler from whatever high-level language you want down to the instruction set. I think the expressiveness really comes from the VM. Now, people are used to various high-level languages, and some are nicer to play with than others. So I do think it's worth making the separation. So I'm just saying that if someone were sufficiently inclined, they could write a compiler from Rust to EVM bytecode, or maybe even from LLVM to EVM bytecode. We're doing this with Cairo. There is a compiler from the intermediate representation of Cairo to LLVM, and we're going to have one the other way around. So people are actually working on this type of stuff. It's not just science fiction.
Absolutely. I'm looking at one. I'm looking at one right now.
Ilya, I want to ask, just press the question. I'm slow to understand. There's the reason Cairo is not just native Rust is I heard two reasons. One is to protect the sequencer from the intermediate representation, to protect the sequencer.
No. It's just a programming language. It's the same thing as, for all intents and purposes, it's the same thing as Rust. There's Cairo, Rust, C++, JavaScript, TypeScript. They're all programming languages.
But the reason they created a different programming language is for twofold. I suppose the main reason is for performance of the ZK.
It's a bit of a historical reason. At the beginning, the first manifestation of Cairo was not very similar to Rust. It was a relatively low-level language.
Yeah, it's very proof-oriented, Jonathan.
It was much closer to C++. You touch the registers with your bare hands. Then we realized that it's not fun to write contracts in such a low-level syntax. So the second the rebirth of Cairo was inspired by adopting Rust in our other engineering endeavors. So now we just made it into a Rust-like language with some extra blockchain context.
The original was what you call Tiny Ram, like more Tiny Ramish?
I guess so. It's called Cairo 0 now, but it was relatively similar. And the high-level language is also unrelated to the intermediate representation. Again, you could build a compiler from whatever high-level language you want to whatever intermediate representation. I want to separate between all of the levels. The high-level language is the stuff in which you write contracts, which is important for developers to be happy or unhappy or suicidal. The intermediate language is something you can go with if you want to protect from various DOS vectors, and then the assembly is whatever instructions you need to support to be expressive.
A quick question: do you know how is this different from Move, for example?
The Move VM is just a different architecture of a VM, and it has some cool properties. I think they're really aiming to take care of parallelization, if I recall correctly. I don't know the language or the VM well enough to understand, to make the comparison. I can only say that one cool thing that they do in SWI is that the organization of their state is a generalization of UTXOs. Like, the state is not an account-based mapping; it's a soup of objects. And by construction, if you have independent objects, then there is no causal relations between what happens to each of them. This is not the case for account-based states, where if you want to act twice, I need to compare your account after the first transaction to see if you can make the second one. So the object-based state organization is cool. I don't know if it has anything to do with the VM. I suspect not, but I just don't know.
Probably not. That's again different layers.
Agreed.
Okay. Well, that's interesting.
Ilya, what is the current security of the ZK if I use the Cairo stack?
I'm not sure I understand the question. I mean, the bits of security is a parameter you can choose in the Stark protocol. It doesn't have anything to do with the language or the VM. Like, if I view
right. It's rounds, but the rounds will decrease the performance. So, like, when Ellie talk about like very fast prover, what bits of security he talks exactly?
I don't remember if it's 96 or above. I'm not sure. I can check. Yeah, maybe I should say it the other way around. I can check. I think it's 96, but I don't want to say.
Yeah, I think too. But Yoni, my point is that like our choice about ZK technology is also need to take into account the security level that we will require as a Kaspa community, because like it's issue. Because we can be very fast on 96 bits of security, but then people like were like, I will not put my Kaspa inside this thing. It's 96 bit. It's not like so much, or and same with the ZK VMs. Yeah, like we will need to choose our security level, and then our performance will follow our choice.
Ilya, what do you think about the 96-bit?
I think it's a great idea to increase it if you guys want more security. I don't think it will detract from performance significantly. I also don't think the VMs have too much to do with security. I think it's just the cryptography. And I don't know if this is proper or not, but I want to point out that not all Starks are created equals. Even if you fix your proving protocol, some are just much more efficient than others. So there is a recent breakthrough in Starks, which is called Circle Stark, which is a huge allows for a huge optimization improvement, but because it adapts Starks to smaller fields, so the computational efficiency is going to increase at least 100x. So I think the price. Sorry.
Smaller, like beer fields, like 32
Yeah, Merced
64.
31.
Yeah, okay.
So,
Yeah, but in general, all general purpose ZK VMs today, like at least those that are fast enough to use, they are in this way or another built on top of the Stark's proving system, plus minus.
Yes,
Either they use the Fry or
the Stark. The problem with Starks is that the vanilla Stark protocol imposes conditions on the size of the field, and Merced 31 is not very suited for Starks, not because of something Starky, just because the usual Cooley Tucky 50 and the Fry, they need your group of units to be divisible by a large power of 2. And with Merced 31, which equals 2 to the 31 was 1, it's not. So you need a new protocol, and we have invented such a protocol. By the way, I mean people other than me. Such a protocol was invented, and it's extremely efficient. So in practice, the price you will pay for increasing bits of security, if you also take advantage of these improvements, will be probably very small. So I don't think it's a major thing.
Can you
Can't you implement opcodes for several levels of security and just let the app developer decide how much security they need?
Yes.
Yeah, it's on our side. It's our side. We can definitely have the opcode be parameterized. I want to ask, how do you compare SP1? Roman looked into SP1, and also Ilya has information about SP1 versus Cairo, or I'm not sure. I'm comparing the if SP1 is the VM or the language, but I suppose it's the VM. How do you compare the performance of SP1? Do they use Cairo? Do they not use Cairo?
Should I take it? I am obviously
you start, and then Roman will continue.
Okay, so SP1 is a ZK VM. So the thing to compare to would be Cairo, but Cairo is a bit of an overloaded term because it stands both for the VM and for the high-level language. In my opinion, it's already less performant than Cairo is right now, and it will be in a completely different universe once we implement Circle Starks. Circle Starks are not a change to the Cairo VM, but they change the cryptography underlying the VM. But it's not that as soon as we implement support for Circle Stark for Cairo, then everyone will be able to benefit from it. We will do it in a not VM agnostic way. So what I'm saying is that I think Cairo is better now, and I think it will become at least 100 times better once we implement Circle Starks.
100 times? You mean literally, not figuratively?
No, I mean literally. This is what the benchmarks. So I can throw around some numbers if you care, but as far as we're aware, it's at least 100 times.
And the spec for this circuit for the verifier, whoever write opcode and upcode on our side is available? Is it written in what language is it written?
It's written in Rust. I'll put a link first and then say a few more words after. Just a sec.
So I'd like to understand something. If you can elaborate, if you can give some insight on that. We have been. Ilya, right? We have been having different discussions on various types of designs, and one of the designs with regards to ZKVM, which is the, let's say, something like SP1, is where where the L2, which let's make an analogy right now. L2 is the same thing as L1. Let's say we have a Rusty-kaspa, which is a full framework and a stack that does all the basically internal processing. So if I understand it, and one of the important elements that that I see is to be absolutely agnostic with regards to the actual smart contract ecosystem. It's very important to have, on my opinion, complete independence on that in a base layer. Let's put it this way. So what we can do, one of the options that ZKVM like SP1 gives us, for example, is that we can take our part of our code base existing, and again, let's make it analogous to Rusty-kaspa. So we take part of the Rusty-kaspa, the data processing part, and we basically compile it in ZKVM and in something like SP1, and we have basically a provable chunk of the platform here. This can be done by basically effectively transplanting the code and wiring it from different directions. What utilizing Cairo would require, basically, in this context, in this mental exercise, would require rewriting the entire this part of Rusty-kaspa that we would want to do in order to place that on top, or at least, yeah, that's subsection of that, and then wiring it.
Yeah, I wanted to ask you. You want to say something here?
I'm sorry, I cut you off.
I would like to say something, but Jonathan also wanted to say something.
No, you go ahead, and then I'll ask after you.
I want to say this is a very good point, just to restate it in my own words to make sure I understand. You're saying if you can prove Rust, then you get for free that you can prove the execution of your client. So in particular, you can prove the execution of whatever consensus protocol you want. I'm just not sure why you would want to do that if the sequencers on the L2 would be the same ones as on the L1. But I agree with your point. That's what I wanted to say. And the second point is that you can add support for more opcodes. You can do it either at the Cairo VM level or by compiling LLVM2, the Cairo intermediate representation, or by just implementing the RISC-V instruction set in Cairo. So you have at least 3 paths to still get what you described for free. That's what I wanted to say.
So can you elaborate on the RISC-V instruction in
Yeah, sure.
Cairo?
I'll enumerate the 3 things again. So Cairo can express anything. In particular, I can implement the RISC-V instruction set in Cairo, right? I can just write contracts or Cairo code that implement the VM itself, and then it's something you can prove.
So we're talking about VM now, right?
What I said is as high level. I can write contracts that emulate the execution of the RISC-V architecture. The second thing is I can write just a compiler to enrich my language. I can write a compiler from LLVM to the intermediate representation or to Cairo assembly, which basically means I'm still able to natively prove whatever Rust code I want. And the third thing is I can modify the VM itself to increase the instruction set to include a superset of the RISC-V instruction set. So at least 3 paths, and all of them will answer the requirement you raised.
Okay, but right now, just out of curiosity, any ongoing work in any of these directions?
Yeah, all three. All three.
Okay, because I think RISC-V would certainly be very, very. And again, we're talking about now not the, because this is actually it's like we also had a problem initially in our discussions. We kept mixing a VM, a smart contract VM, and a ZK VM, which is a two different things. Like a ZK VM can within itself run different VMs that implement smart contracts. So if you put all that within a virtual box, then you have all these layers of different VMs. It's important to distinguish, and this is one of the slightly challenging parts, because there's a language and there is a VM, and that actually that's what's interesting here, because my goal here behind all this is to make sure to be as forward-looking as possible and not end up in any kind of architectural lockdown, which my initial, like from the scientific standpoint, this sounds very pleasing. From the standpoints of getting hands dirty and actually developing this, this is a detractor. But at the same time, if you basically apply the architectural stance toward that, in fact, having different types of prover opcodes would allow to use different ZKVMs, and thus would allow simultaneously to have all these ecosystems encompassed, from standpoint that you would be able to use and SP1 and Cairo VM. And ultimately, that's what we would want.
Yeah, I wanted to ask on the ecosystem level, what's the size of the smart contract ecosystem? Meaning, how many smart contracts? Like, are there Uniswaps already written in Cairo? You know, those kinds of things, or stable coins written in Cairo. I'm just trying to gauge whether this is still in the baby phase or you're already semi-mature ecosystem.
I think semi-mature would definitely be.
Contracts are easily, just migratable because they're fully just Cairo. Anything Cairo.
First
you
of
don't
all,
have
anything written in Cairo can be used in whatever ecosystem adopts Cairo. You can't copy code from Solidity because there is no compiler from Solidity to Cairo assembly. So there is no instantiation of Uniswap, but we have our own AMMs. The most sophisticated one is called Ecubo, and I can link to it. It's pretty sophisticated. You have pretty much all the stuff you would expect. The things in which the Starknet is not really mature is mostly, I think, MEV related stuff. There is not enough liquidity there to really incentivize people to invest a lot in mining for opportunities. And it's also centralized. The sequencer is centralized, so that's another sense in which it is centralized. Does that answer your question?
Yeah. Can I ask a couple of questions related to performance, please, Ilya? So my first question, like when you talk about like literally hundreds of times performance improvement, can you say a few words related to size of proofs, the recursion, and the folding, and their support in general? Because it's like for sequencing layer, we still aware about specifically proof size is one of the important parameters for us.
Yeah, so about proof size in terms of the payload says like how many kilobytes it is. I am not sure. I can check. I am guessing it would be between a single digit or a low double digit, but I need to check to confirm. In terms of elaborating on where does the 100x number comes from, it comes from two main sources. The most significant one is just the fact that we moved to a smaller field. So in Starks, you execute a program, you fill up a table of numbers, which is the algebraic execution trace, and then you do stuff to it, you manipulate it until you generate commitments, which you send to the verifier, and the verifier does low degree testing. So right now, this table of numbers is filled with huge numbers, like 256-bit numbers, and going down to M31 means that it will be filled with much smaller numbers, and the computations will be much faster. And the second thing is we're improving the protocol itself conceptually. We're adding some lookup arguments with GKR that we don't have now. So they will also streamline the whole business.
Yeah, like as far as I know, like the lookup and the smaller field already implemented in VMs like SP1 and Valida. Like they already have it, and the GKR and the sum check and all this jolt thing, it's going on in parallel. I don't know like really what their state is, but one thing I would say is that because RISC-V ZKVMs use Stark protocol, if you guys improve something in your proving system, everyone else will follow.
No,
So if you improve like 100, no?
This is the I think a key part. You if you want to benefit from an improvement to the Stark protocol, you still have to figure out how to adapt your representation of the VM to suit the new cryptographic protocol. So for example, if I modify the Stark protocol to a Stark prime protocol, then it might require you to arithmetize your VM differently. And we're constructing an heir for the Circle Stark protocol by hand. And people who want to copy the benefit from Circle Starks will have to do this, but it's not trivial work at all. So it's not like
but for example, in Plonky 2, like they allow you to use either the Plonk arithmetization or the AIR of Starks. Like I'm free to do whatever I want, and in ZKVM specifically, they indeed use the AIR as it is.
Mm-hmm. So for Circle Stark, you will not be able to use heirs that are designed for a Stark over the affine line. You will have to modify your Starks, otherwise the protocol will not be able to parse them. It won't be able to prove an interesting statement. You can do this in a naive way. You can probably build a transpiler, right, from stone heirs to from affine heirs to circle heirs, but it won't be as efficient as really knowing your stuff and getting in the gritty of it. So you will probably end up compromising for a non-negligible factor in performance. But definitely, if everyone in the world knew Circle Starks perfectly, then yes, this particular thing would not be an advantage, and the only comparative advantage would be in the architecture of the ZKVM itself, which I still claim that Cairo is a leader in, but it's just a separate level.
I have a question about the Roman. Is you have more questions on this?
And what about recursion and folding? Yeah, like I have question related to recursion and ZK recursion and folding.
So we don't use folding in Starks. If I understand correctly, what you mean, we don't use it.
Performance.
But recursion, we expect to have a sub-second recursion. The time is I'm saying it as if it doesn't depend on the input because it's logarithmic. So for practical purposes, I'm pretending it's just a constant. It's just a constant load. So we expect it to be sub-second. Whether it becomes 200 milliseconds or 20, I don't know. I have no idea. But I think again, this is not a blood oath, but I would be surprised if it were not sub-second recursion. And as far as how does the recursion work, it's just code written in Cairo. Like we literally write the recursive. Yeah, we just write it in Cairo. You could have written an error for it separately, like a verifier ASIC. You could have done that. We just
inside Cairo.
Yeah.
Right.
Ilya,
Mhm.
I wanted to ask, what are
Yeah.
the
Just lazy step.
what are the centralization
Understood.
points
Thank you, Ilya.
in using Kairos? So, I understand that there's no license. The open source it's fully permissive.
I can
That's
triple check,
I'm not
but yes, I
sorry.
have no problem double checking and getting back to you. But as far as I recall, yes. And as far as centralization points, the obvious one is that the repo is under StarkWare. So if that doesn't work for whoever wants to use Cairo, they can always fork the repo and begin developing in whatever direction they want. Give
Yeah,
it
yeah.
one.
I'm asking about like let's say I want to do a simple ERC20 transfer.
Okay.
Will I be able to prove it on my mobile phone, for instance, just to exaggerate?
Yeah, for sure. I mean, you'll have Stu, which is an implementation of the prover. You can, if you have like a WASM Stu, you can, as far as I'm concerned, you can compute proofs on your phone. They can prove whatever Cairo code you want. So I don't see any problem.
And then, let's say I want to do n computations. How cheaper? I want to prove n computations. How cheaper is it to prove the n computations together versus n different entities constructing proofs? Let's say for independent, when there are dependencies and when there are no dependencies. So I specifically, like, when there are dependencies, you can't do it in parallel. That's sequential in time, obviously. But how I'm trying to understand what's a factor of economies of scale. Like, if is there centralization force where proving lots of computation is much cheaper, or larger computation is much cheaper than proving many smaller computations, many smaller steps in the way?
I mean, I think latency is a bit of a factor, so I guess I'll start with a naive answer of how we do it in production right now. Right now, the prover is centralized, but the flow is not I aggregate an enormous program, then run it and prove it. Instead, you do it in pieces. You break up proving jobs into small pieces. You build this is the bottom level of a binary tree, and then you just recurse. So there are many factors here, like the arrival rate of jobs, but TLDR, as jobs arrive, you recurse them together, and then you gradually end up proving a huge program. But like what I'm talking about is just blocks. Starknet blocks arrive at a roughly fixed rate, and then for every pair we recurse them, and then wait for another pair and recurse those, and then we
You're
build up.
describing something that's happening in Starknet, not a necessary dynamic of using Cairo.
Sorry?
Are you describing here something that's happening in your rollup, in your start, or something that's
Yes.
related? It's inherent
Maybe I
Cairo.
misunderstood the question. I see. For Cairo,
I'm discussing only Cairo. Like if I wanna,
yes,
how
I see.
cheaper is it for end user?
Let me think. Okay, I'll just say my thought process out loud. You'll probably figure it out much faster. If I want to prove, suppose the statement I want to prove is the execution of some program with n steps, then I can either do that sequentially. So that's the least number of steps, but it might take me a while. Or I can break it up into smaller pieces, but I need to pay a fixed overhead for each piece because of the recursion. So that will take me more steps in the sense of computational resources, but it will take me less time because I can do it
But you don't
parallel.
need recursion. Let's say the verifier will work and will verify each step.
Oh, if I verify every step separately, then yeah, maybe you'll have some small overhead which is fixed per job because you might want to manage the state with some operating system program. Well, basically what I'm saying is that if the statement you want to prove is not a very raw statement, but it's packaged, something like some operating system has enforced the following state changes to the state of your rollup, then the execution of this operating system is a fixed cost that you have to pay per job. So if you prove very big programs, you're paying this overhead once per a lot of computation. And if you're doing it for very small blocks, then you're potentially the fixed cost becomes dominant. I don't know if that answers your.
So for small transactions, it's dominant. The overhead is dominant.
Yeah.
And how does your anchor change whether there are dependencies or not between the n steps of computation?
I don't think I understand what dependencies have to do with it. At the end of the day, if I know the execution trace of my program, then when I break it up, suppose I want to break it up into just two pieces, If I know everything, if I have finished executing everything, then I know the end state of the first part ahead, so I can input it as a hint to the initial state of the second part of the proof. So I can do things concurrently as long as I know the entire execution trace of the program. I don't need to wait. But perhaps I misunderstood.
Okay, so you understood. So more, maybe I'll ask more explicitly. How does Cairo work with parallelism? Is it the best at parallelism? Is it like how
Okay,
easy is
so
it to utilize
I
independent
think
components of computation in Cairo?
I think I think I still don't really understand the question. For example, the sequencer right now for Starknet has parallelization in the sense that it has a Rust code which manages execution concurrently. It has a bunch of threads. It looks for it assumes transactions don't have dependencies and it tries to execute them in parallel, and then it redoes things if things are stuck. This is at the Rust level, but I don't understand why you would care how Cairo does this. In Cairo, what the statements which we're proving is that there is a Cairo program which is called the Starknet operating system, and this program receives blocks which are chunks of transactions, and it manages the state of Starknet by applying state changes following the execution of transactions. Now, this program, this operating system, its implementation is not concurrent, and if it were, I don't understand what you would have to gain from it, because you would only end up making the execution trace of this program larger. The thing which you're trying to optimize for with concurrency is the speed of execution. The speed of proving is only a factor of the amount of computation you have. I don't understand how it would benefit you uh, to prove the concurrent computation of something if it involves more
No,
computation.
but I wasn't asking necessarily about the prover, about Cairo itself as a language. Just putting the prover aside.
Oh, I see. No, Cairo has. I don't think anyone invested in making it super parallelizable. It's not like Rust in that regard, but I think it's easy to make it. So I'm just not sure why you would want to do it.
Make it so.
Yeah.
Why would you want to do it?
Yeah, I'll explain why I think you don't want to do it, because there is a project which I think circumvents the need for this, which is a compiler from the Cairo intermediate representation to MLIR. MLIR is like an intermediate level language, which is a bit higher than LLVM, and it compiles down to native instructions. So if what you care about is fast execution, you just compile down your Cairo intermediate representation to MLIR to whatever native opcodes you want, and in particular, you benefit from whatever parallelism is supported by LLVM or MLIR or whatever you want, if that makes sense.
Okay, it makes sense. It's a bit above my pay grade. Roman, does that make sense?
Yeah, like
Figuratively,
yeah, for sure. Like they don't need to support this parallelism. I understand why, but yeah. But if we think about native Rust, like native Rust just gives to you and you don't need to care about it. But in a ZK level, it doesn't make any sense to have it parallel, because in the end you look on the same execution trace and you can divide it internally, but from perspective of Cairo or so-called Rust that you execute, it's parallel or not, it's still the same execution trace from the beginning to the end. So yeah. Yeah, maybe I have a question about reproducible builds, because I know that in the ZK world, like this is like huge. It's not an issue; it's uncomfortable stuff. Like I want my builds to be reproducible when I go from one compilation step to another, because otherwise I cannot rely on a pre-known hashes. I need to somehow make this new hash available when to the verifier. So when
you mean deterministic?
Yeah, deterministic. Yeah,
Okay.
like bit accurate or yeah.
All right.
when you talk about these three directions that you are guys taking with Cairo, with go through LLVM intermediate representation to other architecture, do you guys take thinking about how hard it will be for you to be deterministic in this sense? Because it's huge need in the ZK world to have the same hash of the execution.
Let me just repeat the question so I make sure I understand it, and I'm not answering the wrong question. You're saying, suppose I write a Cairo program or a Cairo contract, and I identify it by its code hash or class hash. The problem you're trying to solve is that I don't compile the same code to two different hashes. This is the problem?
No, with Cairo, I sure you already to take care about it. It will be same hash. But when you start, when you explain us about three different directions, when you take the intermediate representation and you start, take Solidity or Rust, compile it to Cairo, in all those steps, you need somehow to preserve your caches, right? Because the Uniswap guys, they will provide you a sealed code of Solidity that they are fully audited, and we are
I see. Yeah.
it's
So
our code. And
I
now
see.
you go through three compilation steps, and each one of them should be deterministic, and
Yes,
it
agree.
can be very difficult to make it deterministic.
Agreed.
Because low-level languages like C++, or Rust, they support this stuff natively. It's still hard to do it properly, but it's supported. But for high-level languages, it can be a huge issue.
My answer is, I think this is beyond my pay grade. I don't see any obvious reason why it won't be so. I think it's just an engineering problem, which I think can be resolved. I also think it's only a concern in one of the three paths, but I don't think it's a problem. I don't know. I can look into it.
I can elaborate a bit on that, which is the determinism is the function of a tool chain, because compiler will always produce, given the it's a program, right? So given the same execution environment, it will always produce deterministic output. The problem typically caused by determinism interference is by the fact that during the compilation processes at different stages, compilers include different data, or they perhaps might be somehow dependent on, let's say, execution environment, CPU. The most classic situation, as in Rust, where, let's say, file name paths or date and time can be embedded in the executable. If you remove that, you actually get fully deterministic builds. So this is what typically the issues are. In Bitcoin, for example, every build that is produced of Bitcoin Core is deterministic. But it's largely a function of the build toolchain, and is typically on a case-by-case basis. Just to give the rundown on that.
Yeah, this is definitely above my pay grade.
Okay. Guys, Yoni, you're muted.
Yeah, I wanted to add two directions to the conversation. One is, while Ilya is very bright and extremely informative and articulate, we shouldn't restrict this discussion only to Cairo. Thank you very much, Ilya. We hope you stay around and feel free to remain in the stage. I just wanted to ask, maybe specifically Roman, two questions. One is, do you want to survey other techs briefly do you want to share your survey of other tech briefly? That's number one. Number two, perhaps provide some context to the DAG enthusiasts about how all this interacts with how unique, or how does it look like from an opcode perspective to talk with a DAG. basically the verse 1 that we spoke of, and where you want to take it, your dreams, and do you see it compatible with this ZK VM or another? Just a few minutes to give this context.
Yeah, so we are currently like our maybe top
Otherwise,
two
I'll need
candidates.
to do it. So Roman, come on.
Yeah, I'm here. Do you guys hear me?
There's a bit of
No?
lag, but otherwise it's fine. Yeah, we hear you fine. There's just lag in general.
Okay.
So treat this as walkie-talkie.
Yeah. Okay. So currently we have
I
our
can't hear
maybe
Roman. Can
two
someone hear
top
him?
candidates. It's the
I can see Roman perfectly, just lag. I'll take the second to say to Ilya, please ping me on the development channel, and I'm Aspect, and definitely let's continue this discussion. I am very polygamatic when it comes to technology. I believe that everything should be integrated and supported. So I actually don't view the whole approach here as it's one technology or the other. On my opinion, it should be everything. We should be supporting everything through perhaps different types of opcodes and such. So definitely there was. It sounds extremely interesting, the work that you guys are doing. Roma, you were fine to me. I don't know why. I guess this thing is also kind of peer-to-peer. So continue.
Okay, so guys, do you hear me now? It's okay?
I do.
Okay, so currently we have top two candidates in ZKVMs. The first one is pretty stable. It's called SP1 by Succinct Lab. And the second one is in its early stage, but it looks very solid. It's called Valida. Both teams, plus minus based on their work on a Plonky 2, Plonky 3 code base. It's a eStark paper. It's like plus minus same concepts everywhere, mixed in some way. They have pretty good performance and recursion and all the good stuff in SDK, like smaller fields, and they try to adapt every new fast and cool thing that come up to from the research. The good thing about them is that they run a native RISC-V architecture, and we have like compilers from a bunch of languages to RISC-V. We already have it. We don't need to re-implement it. It's fully supported toolchain. And from like this point of view, it's very cool. To have something that run natively like ELF executables. We take from our lovely linker and compiler. It can be Rust, it can be C++, whatever. This is on a ZK level technology. We also think we don't forget about gross-16 proving system because it's very stable, and we are aware that maybe we should add one of our verified opcodes maybe should be gross-16, because gross-16 it's very, very solid. It's well accepted by custodians. Sometime in the future, when we have like big funds from the layer 2 running on top of Kaspa, it can benefit when we want to bring some big custodians to take care on the funds. And those custodians, as far as I'm aware what's going on in this field, please, like, if anyone from community has updated information in this regard, please share it with us. But mainly they accepted gross-16. because it's very old, it's very stable. It's been there for like almost 8 years. Ethereum has it like, it's very solid. It has constant proof size, like 288 bytes. It's very small, it's tiny. And yeah, and maybe it also like it is our candidate, not maybe like the top 1, but at least top 3. What else? We like the opcode itself on a layer 1 is it's very simple opcode. It will take as an input the ZK proof, the hash of the UTXO set, subset, not the whole set, and the hash of the transactions as Kaspa layer 1 view it right now in the time of execution of this opcode. And this verify opcode will span the old UTXO and will create the new UTXO. This is like the basic idea of it. Yeah, and it doesn't matter after we implement this opcode, or maybe 3 opcode with different types of ZK VMs. From there on, it doesn't matter will we bring the EVM to be executed behind the ZK backend, or we will introduce our own smart contract system run executed and implemented on pure Rust. And maybe I will slightly touch, like, I'm not the person that if you ask me what path Kaspa should take, I don't know, like, really we should go with Rust or with the EVM, because EVM has DeFi and a lot of DApps and a lot of knowledge, but EVM also has a lot of bad things. Like, it was developed years ago. Now we have a better understanding what is the security on the smart contract level. And I think that new smart contracts level systems will come up based on Rust, but we will see what will happen in the next year, because to implement smart contracts on Rust kind of start to be available like maybe a year ago, because of those new ZK VMs that can run RISC-V architecture, so I can take Rust and compile it. And
support EVM or via Rust. That's the it's not a prohibitive.
Yeah, it's like we can do it, but but I think that from technology perspective, we have our we did our check, and we are aware of what is going on and what we want to use in a layer 1. But on a layer 2, what are the steps that we are want to take? It's more question of product wise and our vision as a Kaspa community. And personally, I'm less. I don't like the solidity. Don't know. It feels that like we as a Kaspa, as a fast layer 1, maybe we should take the path of Rust, but I don't really know. I'm not the person like to take this.
Okay. This does not need to be decided in this meeting. We wanted to lay out the options, give some transparency on the considerations. We will continue discussing this in small forums here or on Discord, doesn't matter. I mean, on Discord or on Telegram doesn't. But either way, we don't need to decide, in this meeting.
It's an architectural. Right. It's an architectural consideration. You're effectively by adopting a smart contract VM, you're locking yourself onto one technology. By adopting again Rust by adopting a pure ZKVM that can run ELF. You're becoming smart contract technology agnostic, and as such, you're able to bring all technologies in the current space into under your umbrella.
Why do you say that why do you say that this choice or another makes it monolithic? Like, as long as the verifier opcode has all 3-4 leading proving systems.
Because there has to be there can be a proving system, but there also has to be a kind of a base layer interface that the technology underneath provides. For example, one of the there's basically it's a question
I think the aspect is really that you build on top. Like you can easily add another proving system inside one ZK file.
But building on top does not mean you exclude others from building on top in parallel, whatever they believe, whatever architecture they believe.
No, they can do. Any actor can do what they want if they just want to use a proving system. It's not. It's not something that because for us to. There's different layers to that from standpoint of implementation. You need to not only just come up with the prover and plug in some technology, but you need to build an ecosystem. When you build an ecosystem, you are building a basically a tool chain and an SDK.
What in the L1 specifically you are alluding to that might exclude others?
Not in L1. But as an ecosystem for L2. If you just stick a prover into L1, that's great, but then you're obviously opening up the ecosystem for third-party developers. That's great. That happens regardless, but you do not have a functional anything because basically there will be kind of a natural. I guess attractive force, and people will come and build things. But what we do sort of want is to, from my perspective at least, we want to build a kind of a toolchain ecosystem which encapsulates L1 and L2, and within the L2 layer provides ability for integration of all possible smart contracts in the ecosystem, and that makes this the most powerful. That this would make this, from my perspective, one of the most powerful systems for smart contract execution.
How do you imagine something that is most inclusive? What would be the design? What would be the design and in what layer?
That's basically by targeting simultaneously L1 and L2. L1 making it agnostic to proofs, but making L2, which is agnostic to smart contracts. Kind of. That's the short answer.
Okay. Shai, maybe we you gauge from the chat whether there are questions or directions that were left ambiguous. Otherwise, I mean, this can go on and hours and hours. So I'm not sure if there's if you want to wrap up, you want to go to the updates. You want to collect questions.
Yeah, well, let's give the audience 2 minutes for questions. If you have any question, then please say it now or forever hold your mouth. Okay, I don't really see any questions. Like, there are irrelevant questions, but
yeah, but that was not 2 minutes. That was like 2 seconds.
Nothing about smart contracts.
I see people very complex.
So let's count to 60.
While we wait for questions, I want to throw the following to Roma. Actually, we have this sort of an issue where if nobody minds, nobody produces proofs, the transactions can day out get pruned along these lines. I'm wondering what. Is there a way, just food for thought, is there a way to become proof agnostic in the sense that we have a specific opcode, but this opcode effectively, it has a sub-opcode, which is like a sub-network ID, where any arbitrary group can choose a specific subnetwork ID and start mining, proofs for it or something like that, or some kind of dynamic registry in the sense that something that allows people to just come and introduce a new type of provers without having to actually update layer one in a dynamic fashion, and something like that, just to think about.
While you collect questions, I just wanted to apologize in the name of Ilya. He had to
Yeah, for sure.
go off
Yeah,
meeting
it's
because
no
of
problem. Like you can take Rust.
Okay.
Yeah, like you can take Rust and like your ZKVM support Rust.
Yeah, and then just use identifiers. So in a way, to make this ZK opcode in layer one, basically agnostic to actual proofs, provided that these proofs are because they need to be verifiable by L1. So the provided that also has to be accounted for.
Guys,
But
I think this could wait for the next discussion.
Sure.
It's a nice food for thought. Can we and should we allow a proof system agnostic verification opcode? Just let this simmer until the next meeting. So, okay, I think we can move on to the updates right now.
I wanted just to mention that Ilya wanted me to apologize on his behalf for hopping off the meeting. He had to go to ECC in Brussels to go back. And then, what did you ask about, Shai? Sorry, what was the, was there a question or no more questions? Back to the updates?
No, I was just trying to wrap the ZK conversation up so we can move on to updates and go have dinner. So. Do you have anything less to add? You're muted.
Not on my side. I think it's a good point to wrap the meeting, unless someone else has an.
So I just want to give the few quick updates. We have updates. Anton, did you finish your updates?
No, I'll just take one quick minute. I'll just summarize this quickly to let everybody know that a few following key points is that roughly in about a week from now, we will have various updates in the ecosystem coming, deploying the in parallel to the current RPC nodes. We'll be deploying new RPC nodes. Those are not yet merged into master, but that's really separate issue. There will be simultaneously a new version of KNG coming out, which has various bug fixes, performance improvements, and some UI, notably multi-page support for transaction view and ability to resize window in Windows, which has been asked a lot. And that's we also, I wanted to mention, I wanted to tweet about, didn't get a chance. We have Python bindings that are being worked on by Charles. It's similar to a WebAssembly for TypeScript and JavaScript, but it allows the Rusty-kaspa framework to be used in Python. There's already functioning RPC and some primitives. This is really exciting because anybody who works with Python can either contribute or start testing and playing around with some of that. That's roughly it. I'll let that, major work coming this in about a week from now with regards to the public node and infrastructure. So combined together with ongoing work being done by George and Maxim on replaced by fee functionality, which allows you to basically submit transaction and after that bump its fee. If the network gets, let's say, congested, you don't realize that, you're able to adjust transaction fee in flight, as well as we're working on a fee estimate system that analyzes the current network load and allows wallets to query the node for the actual suggested fee that then can be used to make sure that the transaction goes through fast under the heavy load. I don't think any of this really is going to be that much of an issue once it goes to the network upgrades to 10 BPS, but these efforts on the current mainnet combined with the new public node infrastructure that everybody is building is going to alleviate the two major issues that have been encountered during the situation a week ago where everything got oversaturated. That's it on my update.
Yeah, I just want to add a small thing. You said that you're working on a fee estimation mechanism. Actually, Michael and myself are right now working on going a step beyond. And instead of just estimating a fee, we want to create an estimation of how long you would have to wait given your fee. So we want to let users use the no starvation property of random selection games, and they can set the fee very low, and the system will say, okay, then it will take approximately 5 minutes, approximately 10 minutes, approximately an hour, or if they set it high enough, they can get to the 1 second.
I'm very curious about that because you don't actually know the network dynamics. So when this mechanism comes online, I can just post a message on Twitter and say, hey, I'm minting a new token, or let's do something, and that will initially that will immediately invalidate that kind of algorithm.
Nobody has a crystal ball, and the approximation is relying on the fact that on the assumption that the state of the mempool isn't going to change too much by the time the transaction has a first inclusion. And of course, the users should be aware of that, and the wallet should be very clear about it's impossible to give nothing more than a rough estimation because, as you said, it could be that in 2 seconds, suddenly the mempool will be flooded. You can expect it in advance. But then you can just use RBF with an updated feed. I mean,
right.
There is limitation to that because, laws of physics and times being linear and all of that, but it's better than nothing. I think
that's very great because that falls into the pattern. That actually allows you to start doing time-based in terms of max, medium, low gets translated into slow, medium, fast type of analogy, and this is really great. But I'll tell you, better. You should work on a crystal ball. That's what everybody wants.
Yeah. Okay.
Regarding the RDF and the wallet, you would want, from a UX perspective, the user to sign, without voodoo photography, just the user to sign a few transactions of the low. Let's say I want, let's say I'm willing to pay up to 1,000 kaspa, but I'm starting my bid at 500, and then instead of the wallet doing the ping pong with me, you should sign it in advance. Shai, do you copy?
I don't hear you very well.
Yeah, I actually don't remember. I need to check with George with regards to the adopted policies, because as long as basically first output is, I think the adopted policy is first output is the same, which should fit into this.
Regardless of the policy, Anton, regardless of the policy, ideally the user would sign things in advance so they don't need to remain online while the bidding process takes place.
Okay, but bidding in a context of what?
The user
offline.
Sorry.
We can take this as offline. And there was just one last update from Super Typo, which is not responsive right now. So maybe one of you could
I can
want to talk about the Kaspa database filler.
Kaspa. So I can take that as well. Which is that Super Typo has kind of completed and still improving a new Rust-based database filler, which has much higher performance for the block explorer. So
database filler, if I understand correctly, is like a software that listens to the node and stores everything in a database, which is useful like for block explorers and stuff like that when you need to access a lot of arbitrary data, right?
Correct. Yeah, okay. And I'm trying to sway him toward also making this a part of the Explorer backend, because kind of the same program can simultaneously actually function as the Explorer backend. But this is a major performance improvement which is needed for having Explorer function with ease on 10 bps at much higher transaction rates. So this is one big check mark that is done in the ecosystem, which is also, so I mentioned Charles. I'll also quickly going to mention that Maxim, myself, and Natasha have been working on PSKT and PSKV, which are basically partially signed Kaspa transactions and partially signed Kaspa bundles. The distinction is that a bundle just carries multiple transactions that can be sweep transactions, which might be needed in certain circumstances. But the base layer of that is PSKT, which is partially signed the Kaspa transaction, which allows for a Kaspa standard with regards to transaction exchange, multi-signing. It can be used to create custom transactions, and there's a WebAssembly interface already in development, as well as the native Kaspa wallet interface. I didn't actually look. I think maybe Natasha has already done that yesterday. But effectively, when you do a multi-sig wallet, you have to create a transaction, then you have to share it between parties or distribute it to multiple parties, and then bring it all to, eventually the last party who signs submits it. as well as there's a variety of other functionality. So this type of standardization has been long awaited, and it's, I would say, at like maybe 80th percentile right now in terms of completion. It had Kaspa has its own properties, so it's a bit different than in other ecosystems, but this is nevertheless a lot of progress has been done in that area. And big thanks to Natasha and Maxim for taking this on. So yeah, that's about it on my end, Shai.
Okay, great. So I think we can finish here. It's been a very long and productive meeting. Thanks everyone for attending, and thank you for speakers, and see you all next time. Goodbye.
Ciao. Bye, everybody.